Ms. Rina, what is the hostname of your server and is it correctly set?
Based on the network topology given in the project, the server hostname must be set as server. A hostname is basically the name used to identify a computer on a network. Instead of remembering an IP address, administrators can easily identify a machine through its hostname. Before making any changes, we first check the current hostname using the command hostname ctl. From the output, we found that the new hostname was OS class. Since this did not follow the project requirement, we changed the hostname using sudo hostname ctl set hostname server. After that, we ran the hostname ctl command again to verify the configuration. The output shows static hostname server, which confirmed that the hostname had been successfully updated. Setting the correct hostname is important because it makes network management easier and ensure that the server matches the network topology provided in the project. In our case, the hostname server clearly identifies the machine that provides DHCP, SFTP, web server, and database services to the client.
Okay, Diva, what IP address is assigned to the server and how do you know it's correct?
Based on the network topology provided in this project, the Linux server must have a static IP address of 192.168.1.254 on its internal network interface. This IP address is important because it acts as the main address used by the Linux client to access all services provided by the server, including the DHCP, SFTP, web server, and the database service. The server was configured with two network adapters. The first adapter used NAT mode to provide internet access, while the second adapter used a host-only network to communicate with the Linux clients. Initially, we checked the available network interface using a command IPA. After identifying the internal network interface, which is ENPOSA, we configure it with a static IP address by editing the network configure file using the command address 192.168.1.254 and net mask was 255.255.255.0. After saving the configuration, we restart the networking service to apply the change. To verify the configuration that we use the IPA show ENP0 asset command. The output will display INET 192.168.1.254-24. This confirmed that the static IP address was successfully assigned to the server. The static IP address is used on the server because the clients need a fixed and permanent address to connect to the service. If the server IP changes frequently, clients may not be able to locate the server, that causing communication problem within the network.
Okay, Tasha, can you explain the difference between a static and dynamic IP address?
On our network, we use both static and dynamic IP addressing, each for a specific reason. Static IP address on the server ensure a fixed address for services like DHCP, SFTP, and database. Clients and configurations can reliably point to 192.168.1.254 and won't break after reboot. This stability is critical because service endpoint must not change. Dynamic IP via DHCP is used for clients, so addresses are assigned automatically and conflicts are avoided. It reduces manual configuration and scales easily as devices join or leave the network. In our topology, the client receives an address in the 192.168.5. In short, static equals predictable service endpoint. Dynamic equals automated, conflict-free client addressing.
Okay, Wayne, I would like to ask, does the server can connect the internet?
Yes, the server can connect to the internet. This is achieved through adapter 1. which is configured as a NAT adapter in VirtualBox. NAT allows the virtual machine to share the host machine's internet connect without needing a public IP address. So on the server, this adapter corresponds to the interface EMP0S3, which obtains its IP address automatically via DHCP from VirtualBoxes, typically in the range 10.0.2. something. To verify internet connectivity, I run the command ping google.com, okay, which return a successfully reply with 0 packet loss. This confirms that the server can resolve domain names and reach external hosts on the internet. So that's all for me, and that's all for our general part of mini project. So next to the individual part.
Hi and Assalamualaikum. My name is Nur Adiba Yuni binti Rosli and I will explain about DHCP. DHCP stands for Dynamic Host Configuration Protocol. It's a network protocol that automatically assigns an IP address and other network configuration like subnet mask, default gateway, and DNS server to a client device on a network instead of someone having to configure it manually. The reason we use DHCP is to avoid the problem that comes with static configuration, such as typos, duplicate IP address, and it takes time to set up every single device by hand. DHCP also centralizes all of that on one server and hands out address on a list basis so they get to use it efficiently and it prevent IP conflict automatically and scale easily even as a device to join the network. In this project, I set up a Linux machine as a DHCP server and a separate Linux machine as a client. The server job is to automatically give the client a valid IP address on the same internal network wherever it requests one. To check that the DHCP service is actually running on the server is I use the command sudo systemctl status isc-dhcp-server. Looking at the output, there are a few things that confirm it running correctly. First, the status line says actively running, which means the service has started successfully and hasn't crashed or failed. Second, in the log line below, I can see the actual DHCP handshake taking place in real time. A DHCP discover from the client followed by DHCP offer, a DHCP request, and finally DHCP pack. That 4-step action in the standard process of DHCP server used to hands out an address, and seeing it happen here proven is the service isn't running. It's actually serving client requests. Now, I will explain about how testing is being done at the client. Test 1. Configure client to use DHCP. First, I use this command sudo nano/etc/network/interface. First, I configure the Linux client network interface to obtain its IP address automatically through DHCP. Instead of specifying a static IP address, the interface is set to use the DHCP. This will allow the client to request an IP address from the DHCP server whenever the network starts. Now, test 2. Restart networking service. I use the commands sudo systemctl restart networking. After making change to the network configuration, the networking service must be restarted. Restarting the service ensures the new configuration is loaded and the client immediately attempts to communicate with the DHCP server to request an IP address. Now we're going to do the test 3, verify IP address assignment. I use this command ip-addr show enp0s3. This command displays detailed information about the network interface. The purpose of it is to verify whether the client successfully received an IP address from the DHCP server. If an IP address appears within the configured DHCP range, it's confirmed successfully communication between the client and the server. Now, step 4. Verify communication within the server. I use command ping 192.168.1.254. This ping test to check whether the client can communicate with the DHCP server. If replies are received successfully, it's proof that the both devices are connected on the same network and can exchange the data packets. Now we are going to do test 5, verify two-way communication. Communication should work in both directions. The server also sends ping requests to the client IP address. successfully reply indicate the routing and network connectivity are functioning correctly between both systems. Now, I'm going to talk about test 6, Internet Connectivity Test. I use ping 8.8.8.8 as a command. Google DNS server is used to test internet connectivity. The Linux server successfully reached 8.8.8.8 with no packet loss, proving that it has internet access. However, the Linux client cannot reach 8.8.8.8 because it is restricted to the internal network only. This is confirmed that the client received a local network access but not a direct internet access. Now I'm going to talk about career IP for the clients. The client should receive an IP address from the range configured in the DHCP server. To verify this, I use this command, ip.r show enp0 s3. This assigned IP address must match the subnet configured in the DHCP server configuration file. For example, it received 192.168.1.5. This IP address indicates that the DHCP server is successfully leased an address to the client. If the client receives an IP address outside the configured range, it may indicate a configuration problem or another DHCP server on the network. Therefore, verifying the assigned IP address is important to ensure the DHCP server is functioning correctly. In conclusion, the DHCP server was successfully configured and tested on the Debian Linux server. The server will automatically assign IP address to the Linux client, and all tests confirm successful network communication. This project demonstrates how DHCP simplifies IP address management, reduces manual configuration, and improves network efficiency.
Formally, my name is Rugen, and for this mini project, my part is the SFTP service. I want to install the OpenSSH first. So now I'm going to type sudo install sorry, typo. Waiting for instant download. Okay, now verify the running. Okay, let's activate the enable this. We can do the next step. Okay, next. So wait. I need to add the performance. As users, user class, choose asset and pay next. So I need to set the password of the user. Step 2, I need to create a directory structure. So sudo directory p/7/p/downloads. Okay, next we will try service accept. Next, I need to open the permission. Send by service. Okay. Service on users and open the file name Outlook. And the function of Outlook. Okay, step 3, I need to edit the SHD config. So I need to inside the file called SSD config first. So tc // so sshd config. Go to the very bottom of inside and enter the patch user. Okay, my group name, my username. So starting p so and now ECP forward. And set and exit. Start first. Restart in is normal. So I try to inside the FFTP server first. Okay. Existing so I can it something like that. So I want to type more. Something like that. And after, so I can access it. So, yes, I want it inside. So, SFTP is connected. So next, I want to test the SFTP. So first, I pdb, also pdb that exists slash, and then I want to upload without the server. Okay, next step access first. So, I want to write the file inside the SFTP server. So intro security inside the SFTP. Then I need to see uploads. Txt. This is the meaning of the upload. Upload the file inside the server, and then I uploading 100% successfully. So now I can see the file inside the SFTP. So now I want to want to run the file download. So download command is get. So we can ask. So fetching the file inside the SFTP. So next step, I want to create a folder. I have one of the file and one the directory. So how to remove the directory file? So first disable the Linux this txt. Remove it. Okay. So now for the SFTP Rapid Q&A. Explain usage of SFTP. SFTP is used to securely transfer file between the server and client over an encrypted SSH connection. In this project, it allows the client to upload and download files to the server without exposing data in plain text, unlike regular FTP. So how testing being done? I test it in several stages. First, I connect using SFTP Fedora Alliance IP address and confirm I got the SFTP prompt. Then I use PWP to verify the cron gel is show / confirming the user is logged inside /srv /sftp and can't access anything outside. So show upload. I use the put command put text file.txt well connected, and inside the uploads folder, the file transfer at 100% successfully as shown in my screenshot. And show download, I use the get command get text file.txt to retire the file back from the server to my local machine. This also complete as 100% confirming the download works correctly. That's all for me for my individual part. Thank you so much.
Assalamualaikum and good morning, Doctor. My name is Nisrina binti Muhammad Qayyum Japri, and I was responsible for the implementation and configuration of the web server service for our operating system mini project. Next, I will explain about the usage of web server. A web server is software that receives requests from users and delivers web pages over a network. Whenever a user enters a website address into a browser, the browser sends a request to the web server. The web server then processes the request and sends the requested web page back to the user. In this project, Aperture 2 was installed on the Linux server. The Linux client accesses the hosted web page through the server IP address, which is 192.168.1.254. The main function of a web server include hosting websites and web applications, delivering web content to users, providing access to information through browsers, supporting communication between clients and servers. Aperture was selected because it is open source, reliable, secure, and widely used in real-world environments. Next, I will explain about step-by-step configuration. The first step was updating the package repository using sudo apt update. This ensures that the latest package information is available before installing any software. Next, Aperture 2 was installed using sudo apt install aperture 2-y. This command installs the Aperture 2 Aperture web server together with all required dependencies. After installation, the Aperture service was verified using sudo systemctl status Aperture 2. The output showed that the service was active and running successfully. After confirming that Aperture was running, the default web page was
modified by editing the file sudo nano /var /www /html index.html. This file contains the HTML code displayed to users when they access the server through a browser. Once the web page design was complete, Aperture was restarted using sudo systemctl restart aperture2. This ensures that all modifications are applied successfully. Next, we go to design of simple web page. For this project, I designed a simple web page using HTML. The web page was intentionally designed to be simple because the objective of the project is to demonstrate web server functionality rather than advanced web development. The HTML file was saved inside /var /www /html index.html. Aperture automatically serves this file as the default homepage whenever a client accesses the server. The successful display of this web page proved that Aperture is correctly hosting web content. Now, we go to the part how testing is being done. Several tests were conducted to verify that the web server was functioning correctly. Test 1. Verify Aperture service. The following command was used sudo systemctl status aperture2. The results show that the Aperture service was active and running. This confirmed that the server is ready to process web requests. Test 2. Verify network connectivity. The ping command was used to verify communication between the client and server. Ping 192.168.1.254. The result shows 0% packet loss. This confirms that the Linux client can successfully communicate with the Linux server through the internal network. Test 3. Verify web content. The web page was accessed from the Linux server using curl localhost. The HTML content was displayed successfully. This confirmed that Aperture is serving the web page correctly. Test 4. Access website from Linux client. The Linux client opened a web browser and entered http://192.168.1.254. The web page appeared successfully on the client screen. This confirmed that the client can access the website hosted on the server through the private network. Now, I will demonstrate the operation of the web server. First, I will show that the Aperture service is currently running using sudo systemctl status aperture2. As shown, the service status is active and running. Next, I will show the HTML file used to create the web page. Sudo nano /var /www /html index.html. This file contains the web page content displayed to user. Finally, I will switch to the Linux client and open the browser. I enter http://192.168.1.254. As shown on the screen, the web page loads successfully. This demonstrates that Aperture web server is operating correctly, the web page is hosted successfully, the Linux client can access the web page through the network, communication between server and client is functioning properly. In conclusion, the Aperture 2 web server was successfully installed, configured, and tested on the Linux server. A simple web page was created using HTML and stored in the Aperture web directory. The Linux client was able to access the web page through the server IP address, proving that the web service is functioning correctly within the private virtual network. Therefore, the objective of the web server implementation was successfully achieved.
Assalamualaikum warahmatullahi wabarakatuh and good morning. My name is Nurul Natasha binti Muhammad Rasif, P152510115. Today I would like to explain about the database server. For the database part of our mini project, I set up the MariaDB server on the Linux server to act as a central place to store company data on our private network. The code was simple. Install MariaDB, secure it, create a database for our network and allow safe access from client machine inside the IP network. I hardened the server by setting a strong root password, removing anonymous users, blocking remote root login, and deleting the task database. I then create a database called CompanyDB and a user named Fedora that is allowed to connect only from the internal IP addresses. Inside CompanyDB, I create a table called employee with the three fields, which is ID, name, and department. And also, I add two example records, Ali from IT and Abu from network. Here is two the setup explained. First, I check the server's network detail and confirm it has an internal addresses which is 192.168.1.254, which is the address client will use to reach the database. Next, I refresh the system package list and installed the MariaDB software so the database service and tools are available. I turn the database service on and set it to start automatically every time the server boots. I then secure the installation by running the built-in hardening step. I set the root password, removing anonymous account, block the ability for root to log in from another machine, and remove the default task database. I set the database console as an administrator, create a company DB database, and check that it was created successfully. I create a dedicated user, Fedora, that is limited to our internal network range only. I give this user the right to use everything inside CompanyDB and apply the changes. I select the CompanyDB, create the employees table with an auto-numbered ID plus name and department, and insert two sample rows. Finally, I view the table to confirm both records were saved correctly. I also run a simple task to prove everything works. First, I check the database service status and confirm it is active and running. First. Second, I verify the company DB exists, that the employees table is present, and that the sample row for Ali and Abu can be read back. Third, I test from a client machine on the same private network by connecting to the server at 192.168.1.254 using the Fedora account and confirming that the company DB is visible and the data can be read. This shows the database is working and it is only reachable from inside 192.168.1 and acts as a plan.
Hi, now is our Q&A time.
Hi Adiba. What is the main function of DHCP?
So the answer is the main function of DHCP is to automatically provide an IP address to the client device so they can communicate on the network without need to manually configuration it.
Okay, Diva, how do you know the HCP service is running?
So Tasha, if you want to know the service is running, so you can just on the prompter, you just write sudo systemctl status isc dash dhcp dash server. So the output will come out to say that the system is active and in the bracket you say it's running. So that's how you're gonna know the service is running. Okay, Woon, my question is what port do SFTP use?
Okay, Diba, actually it's port 22, the same port as SSH, since SFTP runs as a subsystem of SSH rather than a separate service.
Okay, Woon. For the next question, I would like to ask you what's the difference between FTP and SFTP?
Actually, FTP transmits data in plain text and uses port 21, making it vulnerable to interception. And SFTP encrypts all data using SSH and uses port 22, make it much more secure. Okay, Tasha, why use Fedora Alliance IP address instead of letting any host connected?
Okay, Boon, that is great question. And this is interesting because this limit login to our private subnet only, which is more safer than allowing all networks.
Okay, thank you, Tasha.
Okay, Tasha, my question is, what does the security script do?
Okay, Diva, thank you for the question. And the answer for your question is because it set a strong root password, remove the anonymous user, and block remote root login, and also delete a task database to reduce the risk. Okay, Nis, now your turn. I would like to ask you, what is the function of Apache Web Server in this project?
Thank you, Tasha, for the question. Apache Web Server is used to host and deliver web page to user through a web browser. In this project, Apache was installed on the Linux server to provide web content to the Linux client over the internal network. So, when the client enters the server IP address, Apache process the request and display the web page.
Denise, how did you verify the web server working correctly?
Okay, thank you, Woon, for the question. So I verified the web server by first checking the Apache service status using sudo systemctl status Apache 2. And then the output showed that the service was active and running. And then I accessed the web page from the Linux client using http double dot double slash 192 dot 168 dot 1 dot 254, our IP address lah. And then the web page loaded successfully, confirming that the web server was functioning correctly and could be accessed through the network. That's all.
Okay, that's all for our Q&A question time. Bye.